Good day everyone. Today we will be discussing about mean-shift algorithm, one of the many clustering techniques used in data science and machine learning. Mean-shift algorithm is an unsupervised clustering algorithm that aims to discover blobs in a smooth density of samples. It is a centroid-based algorithm that works by updating candidates for centroids to be the mean of the points within a given region, or also called as a bandwidth. So additional info is that mean-shift algorithm is called a non-parametric because it does not assume a fixed number of clusters beforehand. So unlike other algorithms such as k-means, where you must specify the number of clusters, mean-shift on the other hand finds the clusters automatically based on the density of the data. These candidates are then filtered in a post-processing stage to eliminate near duplicates to form the final set of centroids. So therefore, contrary to k-means, as I've said, we don't need to choose the number of clusters ourselves. So simply put, mean-shift lets the data speak for itself to determine how many clusters exist, which is particularly useful for datasets where the number of clusters is unknown or is difficult to estimate. So this property makes it powerful but computationally heavier compared to algorithms such as k-means. Mean-shift iteratively moves a window towards regions of higher data density. It does this by calculating the mean of the data points within the window and shifting the window center to this mean. So this process is akin to climbing a hill, with the peak representing a high-density region. So let's imagine a situation where you are in a hill. So mean-shift algorithm is like a ball rolling down the hill, always seeking the highest point of the hill. So it starts at a random point, and then it calculates the average height of the nearby points. So then it moves towards this average, repeating the process until it reaches the peak. So these peaks are the clusters in our data, where the density of points is the highest. By finding these peaks, mean-shift helps us group similar data points together. So next, we have choosing the right bandwidth. So the bandwidth in the mean-shift algorithm is one of the focal points of this algorithm because it defines the radius of the window used to estimate the density of points in the feature space. So it determines how neighboring data points influence the clustering process. A larger bandwidth smooths the density estimation, while a smaller one makes it more localized. A small bandwidth can result in many small clusters, whereas a large bandwidth can merge clusters and produce fewer groups. So choosing the right bandwidth is critical in mean-shift algorithm and can be done manually. So using methods like cross-validation can help. So the bandwidth directly impacts the algorithm's performance by balancing over-segmentation and under-segmentation of data. So here are the important characteristics of the mean-shift algorithm. So first, we have no predefined number of clusters. So what it means is that the algorithm is the one which automatically determines the number of clusters based on the data's density distribution. Hence, we have no predefined number of clusters. So unlike k-means, we don't need to predefine the number of clusters first in mean-shift algorithm. So next is bandwidth selection. So the bandwidth parameter is, as I've said, the focal point of this algorithm. It is critical because it controls the size of the kernel and impacts the clustering results. So here we have the code. So first we of course import pandas SPD, the imported libraries. Next is we read the CSV file, which is the mallcustomers.csv, and then we do the data pre-processing to make sure that the dataset is organized, clear, and clean. We have here printing the head, the shape. We check if there are null values in the dataset, and then we see if there are any duplicated values in the dataset. So we have here none and no null, and then we drop the necessary columns, which is the customer ID. So we're only left with these features. So next is, after the data processing is done, we now head to the actual implementation of the mean shift algorithm. We select the pair of features that we think will get us the perfect clusters. So I chose annual income and spending score, and then we just print it to make sure that the data points are all set and the features are here as well. So next is we import some specific libraries such as sklearn cluster, mean shift algorithm, mean shift and estimate bandwidth. So here we have this. So the estimate bandwidth function just determines the bandwidth by analyzing the distances between points in the data. So the quantile 0.1 specifies that 10% of the nearest points will be used to estimate the bandwidth. So 200 because we have 200 samples, and then we do the actual mean shift algorithm. So we fit it in the model. So the dataset X features. So we have here the mean shift bandwidth. It initializes the bandwidth of 16.83 number plus plus plus, which defines the kernel's radius for clustering. So the bin seeding equals true parameter speeds up the algorithm by using a grid of points, or called bins, to seed the initial cluster centers rather than all the data points. So here we have the labels. Labels just means to retrieve the cluster labels assigned to each data points. So cluster centers just means that we store the coordinates of the centers for all the clusters identified by the algorithm, and then we just print it. So print the unique labels to extract the unique cluster labels, and then for the clusters we just calculate the total number of clusters by counting the cluster centers. So here is the actual implementation of the code. So we see here, we visualize the mean shift algorithm. So this code here visualizes the results of the mean shift clustering using a scatter plot. So we import the necessary libraries. So the first PLT scatter plots the data points from the dataset X with their assigned cluster labels using colors from the Viridis color map to differentiate clusters. So the second one here, it highlights the cluster centers with black X, and then so here we just print the labels and then show, and here we have the actual visualization of the mean shift. So this image shows the results of the mean shift algorithm. We have here 7 cluster centers, 1, 2, 3, 4, 5, 6, 7, as we know here. So this just means that we have the clusters for, so for example here we have the yellow green, which represents high income high spending. We have here green, which represents low income low spending. So cyan or light blue or blue green here to represent low income to moderate or high spending, as we can see here. And then middle income high spending is dark blue, and then high income low spending is color yellow. So we have here high income but very low spending. So here the purple, which is middle to low income to moderate spending, and then the color blue, which is middle to high income and low spending. So that's the visualization of the data. So all in all, we found out that through this report, the mean shift is a practical clustering technique that doesn't need you to tell how many groups or clusters to make. So our goal in mean shift is to find the right balance between small bandwidth and large bandwidth to acquire the optimal meaningful clusters, and we don't encounter issues such as under-segmentation or over-segmentation. So we saw here how mean shift can group customers based on their spending habits, income, that reveals their patterns. So this can be useful for businesses to target specific customer segments with tailored marketing strategies, and through mean shift we can further understand the clusters of the customers in order to make smarter decisions and apply appropriate decisions according to each clusters. Thank you for listening, and I hope you learned about the mean shift algorithm.